Here we will look at subtracting mixed numbers using area models. This standard builds on the work students did in fourth grade, where they subtracted fractions, including mixed numbers, with like denominators. It also requires students to apply what they learned about finding equivalent fractions, since their work in fifth grade will involve fractions with unlike denominators using related fractions. Related fractions are like what you see here with 1/3 and 5/12, where one of the denominators is a multiple of the other. Students are also expected to use benchmark fractions to assess the reasonableness of their answers. Students should have ample experiences using models to build understanding and to allow them to use reasonableness to find a common denominator prior to using the algorithm. Let's take a look at using area models to solve 5 and 1/3 minus 2 and 5/12. To begin with, we'll estimate 5 and 1/3. We know that fraction 1/3, we could say that's close to 1/2. I know that half of 3 is 1 1/2. And I know that with fractions, when the numerator is half of the denominator, that fraction is equivalent to 1/2. And I know that 1 is close to 1 1/2. So 1/3 is close to the halfway point. So we could say 5 and 1/3 is about 5 1/2. And then 2 and 5/12. When I look at that fraction 5/12, I know that it is just 1/12 away from 1/2, and it is 5/12 away from 0. So it is closer to 1/2. So I could say that 2 and 5/12 is close to 2 and 1/2. Then I would subtract 5 and 1/2 minus 2 and 1/2, and I will have 3. And so that lets me know that our actual answer should be around 3. So to begin, I'm going to go ahead and model the 5 and 1/3. So I know I'll need to show 5 holes. And then I know I'll need another hole to show the 1/3. So I'll go ahead and split that one into thirds. And then we'll shade in what we have. So we have 1, 2, 3, 4, 5, and 1/3. And we know that from this we are going to subtract 2 and 5/12. So I'm going to model that as well. So we're going to subtract 2 holes. And then I'll need to show the 5/12. So I'll draw another hole here. And I'm going to split this one into 12ths. And I'll go ahead and shade in 2 and 5/12 now. So we have 2 holes and then 5/12. So 1, 2, 3, 4, 5. So again, what we have shaded in blue is what we need to take away from our 5 and 1/3. So right away we could see that we can easily take away the 2 holes. So sometimes people like to start by doing that. So we can go ahead and do that. I'm just going to cross off 2 holes. And then we can just kind of check these off to know that we've already subtracted them. Now I see that I need to take 5/12 away from what I have remaining, which is 3 and 1/3. The first thing that I'm going to need to do is split my model for thirds into 12 equal parts so that I'd be working with a common denominator of 12. So let me begin by doing that. I know that if I split this into 4 times as many parts, I would have twelfths now. So let's see here. If I do this, I now have 12 parts instead of just 3. So we'll count that to show you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this shows me that my 1/3 that I had here is actually equal to 1, 2, 3, 4, 4/12. So now that I'm working with twelfths, I could easily subtract, except that I see down here I have 5/12 that I need to subtract. However, up here in yellow, I only have 4/12 shaded in. And this part can be a little tricky sometimes. What we need to recognize though is that over here in these 3 holes, we have a lot of twelfths. We have 12/12 in each one of those holes. So what we will do is we will just simply break one of these holes into twelfths as well, and then we'll have enough twelfths for subtracting. So again, what we're going to do is split this whole into 12 equal parts as well, because one whole is equal to 12 twelfths. And now what I have is I have the 4 twelfths that I already had, and I have 12 more twelfths. So I really have now 16 twelfths to work with, and that's more than enough to be able to subtract the 5 twelfths that I need to. So let me go ahead and do that now. I'm going to cross out 5 twelfths. So 1, 2, 3, 4, 5. I'm just going to check them off down here. You could do that one at a time or the whole thing, either way. But I know that I subtracted all 5 of those twelfths that I needed to. And so now my job is just to look and figure out how much do we have left, because that will tell us the difference of 5 and 1/3 and 2 and 5 twelfths. So I can see that we have 2 wholes left. We have one whole there and another one here. And then I see that in this next hole, only 1 twelfth was subtracted. So I know that there are 11 twelfths left. So that lets me know that the difference is 2 and 11 twelfths. So I can say that 5 and 1/3 minus 2 and 5 twelfths is equal to 2 and 11 twelfths. And I know that answer is reasonable. When we estimated, we said that our answer should be around 3. And I know that 2 and 11 twelfths is just 1/12 away from the estimated answer of 3. That lets me know it's quite reasonable. So again, this is how we can use area models to subtract mixed numbers.